Greetings all. Let's talk about some complex rational expressions. Whenever I say the words complex rational expressions, it's a fancy way to say double fractions. Or you got fractions inside your fractions. Now, here's something that they taught you back in 4th grade. I'm going to do 4/5 divided by 1/10. And what did they teach you to do? They said you take the second fraction and flip it over, and then you multiply. In fact, we just did simplifying rational expressions, and I told you the same thing. I said flip it over, and then make it a multiply. And just like you can do with rational expressions, sometimes you can do some reducing before you even do the multiply, and you end up with the right answer. Now, what I want you to do is I want you to grab a calculator, and depends on if you're in classic mode or math print mode, you might want to be careful, but 4/5 divided by 1/10, I just want you to punch it in the calculator. If you're in classic mode, I always say play it safe and put everything in parentheses. But the thing is, you should get 8. But when you think about it, 4/5 divided by 1/10 doesn't seem like the answer is supposed to be 8. It seems kind of weird. But fraction division is kind of weird. For example, you flip the second fraction and multiply it, but no one ever told you why. I'm going to tell you why. See, when you have a 4/5 divided by 1/10, what you technically have is what I call a double fraction. You have a fraction inside your fraction. And if you have a fraction inside your fraction, well, this says 4/5 divided by 1/10. So I could write it like that. But here's the whole trick with why do we multiply by the reciprocal of the second fraction? Well, it's because if the bottom number here, if this bottom number down here was 1, then I wouldn't have to write it in. And if I didn't have to write it in, it wouldn't be called a double fraction. You follow my lead there? If this number down here was a 1, then I wouldn't even have to write it. But the thing is, it's not a 1. How do I make it look like it's 1? I multiply it by 10. Now, if I multiply the whole bottom of this fraction by 10, it's going to cross cancel, and I will get 1 on the bottom. I will. Problem is, you can't just multiply the bottom of a fraction by 10 and not do anything to the top. If you're going to change something, you have to multiply top and bottom by the exact same amount. See, what I'm technically doing is multiplying by 10/10. And we all know 10/10 is the same as 1. And you can multiply anything by 1 without changing it. But what happens then? In the bottom, let's recap. In the bottom, my 10's canceled. I got a 1. In the top, hey, guess what? That could cancel. I'd get a 2. 2 times what? What? There it is. There's my 8. So the beauty of this is we tell you guys to flip the second fraction because it's the same as multiplying top and bottom here by the reciprocal, which is totally a legal, legit move. But that's why. Now, if it was this easy, though, like if I gave, I'm not going to give you on the test 2/3 divided by, 4/5. I'm not going to do that. I'm not. But you could punch that in on a calculator. But the trick we're going to use is kind of based on what I did right here. See, this is a complex rational expression. It's got a fraction inside of a fraction. So let's look at 2/3 over 4/5. And here's what I'm going to show you to do. I'm going to tell you to multiply the top by 15 and the bottom by 15. Why do you think I picked 15? 15 is the least common multiple of the two denominators. But what that does for me is it lets me get rid of this. 3 goes into that 5 times, so 2 times 5. 2 times 5, the top part is 10. Let's do this. 5 goes into 15, that's 3 times. 4 times 3, that's 12. And then I say 10 twelfths, I could reduce that, and I could call it 5/6. And you say, why would I ever do it that complicated way? Why are you trying to make me crazy? Well, because as you might have guessed, this would not be on your test. 2/3 divided by 4/5. You could do it on a calculator. Let's look at stuff that is on your test. And by the way, what I just showed you is what I call type 1 complex rational expressions. There's 2 types. They're easy to spot. Let me go through a couple so you can see what I'm talking about. But when all is said and done, I want you to know this. Ah, crud, that's not what I want you to know. What happened to my stuff? Where'd my stuff go? There it is. Oh my God. My home screen. So anyway, here we go. When all is said and done, look. Here's the assignment. You're going to do these 4 problems right here. And then you're going to do these 4 problems right here. Because I don't want you to do this one or this one. We're not at that stage of the game yet. But 55, 57, 59, and 60. And then once again, of course, here's an answer key. You're going to see a key for it. See, all of these ugly... Look at number 60. Look at the answer for 60. Look at how 60 starts. This is why algebra can be so frustrating sometimes, because you can have something really complicated looking that turns out to be, -1. -1. But how do you get there? You have to learn how to process all this stuff. So let me do my best to show you how to process this information. And here is a type 1. This is the same type of trick we just did. I showed you a trick, what I want you to do to clean something like this up. But you know what? What did I show you? I showed you, I think it was 2/3 divided by 4/5, right? And then I showed you multiply top and bottom by 15 because you can knock it out. The only reason I showed you that is that's what you would do if this was a type 2 problem. See this right here? This isn't a type 2 problem. What do you mean? I'll tell you in a second. If you see that it's like this with 1, 2, 3 fraction bars, you would never do it the complicated way. You would do it the 4th grade way. When you see 1, 2, 3 fraction bars, you just go like this. 2/3 divided by 4/5. You flip it, you multiply, you have a few laughs, you call it a day, whoops, and you get the question finished. So, take a look at this guy. I'm going to use a red pen for a second. There is 1, 2, 3 fraction bars in my original problem, which means this. I am going to treat this type 1 style. So type 1 style, what do? It's very simple. Rewrite in division format. So how do you know it's type 1? You see 3 fraction bars. That's how you know. So guess what? I'm going to rewrite this one so it looks like this. 6 over x plus 2 divided by 12 over x squared minus 4. That's what I'm going to do. In fact, you could have saved yourself a step, and you could have said, well, can I just flip this in my head and write it like a multiply? Could I have just written it down like this to begin with? And the answer is, yeah, you could have done that. See, when it's type 1, there are 3 fraction bars. What do? You rewrite it like you did in the 4th grade. And then you go, oh, wait a minute, that's difference of squares. X plus 2, x minus 2. Hey, I can reduce stuff. I could take this guy and knock it out with that guy. 6 goes into itself once. 6 goes into 12 twice. The final answer is x minus 2 over 2. Bam, done deal, you're finished. Yes, you are, that's it. Let's take a look real quick at another type 1 problem. And you might look at this and say, well, that looks more complicated to me. Okay, but the first thing you have to do is count how many fraction bars. There's one of them. There's a second one. There's a third one. If there are 3 fraction bars, you are going to rewrite in division format. That's what you're going to do. So you go, oh, okay, I could do that. I'm going to say 3 over 2x squared minus 10x divided by 15 over x squared minus 5x. And you might still be saying, could I have cut out that middle step and done this in my head? Yes, you could have. Whenever you do double line with an arrow in mathematics, it stands for implies that, or could be that it means this also. So that's a fancy way to say implies that. So I'm going to say times, and then there's x squared minus 5x over 15. And then you say, well, I can't factor that. Sure you can. Look at how GCF-erific that thing is. That is GC fantastic. Don't forget, GCFs are fantastic. So what do? Well, in the bottom I could take out 2x. And I'd get x minus 5. In the top I could take out an x. I'd get x minus 5. And then let's just start knocking stuff out. Look, I'm going to use a blue pen so I don't lose anything here. Change colors. And it looks fresh. I'm going to knock you out. Mama said knock you out. And then look, 3 goes into that 5 times. So wait a minute. What's left in the top? There's nothing there, but please don't put a 0. What holds the place in the top? A 1. Ooh, that's a really bad looking 1. I can do better than that. Let me see if I can make a better looking 1. 1 over, and then, oh, don't forget the little stuff. 2 times 5 is 10. See, this horribly complicated looking thing is no more than 1/10. That's what it is. So when you see the homework questions I have, you'll notice the homework questions are big, beefy things, and then they end up being tiny answers when you're done, because you're going to learn how to simplify stuff. All of the problems we have looked at so far are type 1. Let's talk about type 2. Type 2 is the kind where you have no choice but to multiply the top and the bottom by the LCM. So, how do you recognize that it's type 2? Okay, if it's type 2, it's got more than 3 bars. That's how you know. Look at this. There's 1 of them, 2 of them, 3 of them. That counts. 4 of them. There's 5 of them. That is more than 3. So you know what I'm going to do? I'm going to multiply by the LCM, the least common multiple. Now the least common multiple is the same concept as the common denominator. It is. When you're trying to get a common denominator in algebra, yes, you have to represent everybody. The least common multiple is the same concept. So look at this. This guy right here, he's got an x. I got an x. Okay, x is going to be part of the LCM. I'm a 2. Well, I'm a 4. I'm slightly bigger than you, so I am cooler. So what are you saying? It means I'm going to multiply the whole top of this fraction by 4x. I'm going to multiply the whole bottom by 4x. And technically, if I multiply the top and bottom of this fraction by 4x over 4x, I'm really just multiplying by 1, so I don't change a thing. But what happens? You get rid of the double fraction look, okay? So a type 2 problem, you're going to multiply the top by something. Let's just see what happens here. If I multiply the first two pieces together, then the x is going to cancel with this x. I'll get left with 4 times 6. What's that? It's 24. Plus, 2 is going to go into this twice. I'll get 2x times 1. That's just 2x. So, is the top part cleaned up? Yeah. Does it have a GCF in it? Yeah. Is it technically in an impolite order? Yeah. All those things are true. But you know what? Let's see what the bottom brings me. When I do this times this, the x's would have canceled. I'd get a 4. Minus, the 4's would have canceled. Here I'd get an x. So here's the thing. That answer is technically not wrong. It's a little bit sloppy. Like, if you wanted to make your friends happy, you would put the 2x and then the 24. You would put the negative x and then the positive 4. That would be the cleanest way. That would be the most mathematically polite way to do it. But guess what? I can't reduce this problem. I can't just say, hey, I'll knock the x's out. Hey, I could put 4 into 24. I don't get to do that kind of stuff. That is not valid. The top part's a binomial. It doesn't match the bottom part, which is a binomial. You leave it alone. You're done. That's your answer. Congratulations. That's the answer. Woohoo! Let's go to another type 2. Let's take a look at this one. Now look at this type 2. How do I know it's type 2? Count how many fraction bars you see. There's 1, 2, 3, 4, 5 in my book. So I'm going to take the whole top and the whole bottom, and I am going to multiply it by the LCM. What's in the bottom? There's x's and x squareds. Who do you think is cooler, x or x squared? The guy who's got the most is the coolest, so x squared is cooler. So I'm going to take the whole top, and I'm going to multiply it by x squared. I'm going to take the whole bottom, multiply it by x squared. Why? Because this is not a type 1 question. If it was a type 1 question, I'd rewrite it like a division. But there's way too many division bars in this one to do it cleanly. This is going to get me done faster. Watch. X squared times the first part. One of those x's cancel. I get 5x. Plus, guess what? The whole thing would have canceled on the second move here. I get a 2. The whole top is done. Look at the bottom. X goes into one of these. I get left with an x times 6. I get 6x. Minus, x squared would have gone all the way. So what am I left with here? A 3. The top part's a binomial. The bottom part's a binomial. Do they match exactly? No, they do not. But wait, I could take a GCF out. I could leave the top alone because there's no GCF. I could take a 3 out of the bottom and then say 2x minus 1. Well, look, does this binomial match this binomial? No, it does not. Did taking out a GCF actually help you reduce? No, it did not. So here's the rule with this. If taking out a GCF does not help you reduce, you don't have to do it. But what if I do it? You said do. Then you're right also. They're both correct answers. They're both legit. That's the way it works. Now, let's look here. Because I got a couple more. I want to make sure we hit all these bases. And you go, wait a minute, there's only 3 fraction bars. This is type 1. Okay, to every rule there is an exception. Okay, See how I could make this look like a fraction if I wanted to? I could make this look like a fraction if I wanted to. That's what I'm supposed to do. If you can make the problem look like it's got fractions in it, then you do it, and then you count how many fraction bars. So now I look at it and I go, oh, I'm back to 5 fraction bars. So this is definitely type 2. But this time, look, there's a binomial in the bottom. I got a binomial too. Hey, we both match. Guess what? That's my LCM. Let's use a blue pen. I'm going to take the whole top of this thing and the whole bottom of this thing, and I'm going to multiply the whole top part by x plus 2 and the whole bottom part by x plus 2. As long as I multiply the top and bottom of any fraction by the exact same thing, I'm technically multiplying it by 1. That's what I'm doing. So watch out here, because the first part is just going to be like this. It's x times x plus 2. That's what I get. And then the second part, when I do this part, the x plus 2's are going to drop out and I get left with minus 1. Okay? Now, do you guys see that I could do a little more math here? I totally could. If I did just a little bit more math, I would have another answer. Here, I'm going to write it down below here. I would have x squared plus 2x minus 1. That's what I would have. Well, let's finish the bottom part. Let's see what the bottom part turns out to be. If I did x plus 2 times 5, I'd get 5 times x plus 2. And then on the bottom, if I did the second part, these guys would have canceled. I would have got a 3. And then do you see how I still have a move I can make here? I could say 5 times x, that'd be 5x. 5 times 2, that'd be 10. There's a 3. Now here's the thing. Never do this. This is such a never ever in the world. Don't do this. Bam. I'm going to get rid of those 2 binomials. You don't get to do that. You have to clean it up first. So what I just did with the green pen is a big old no-no. I'm going to erase it. Never cancel before you combine. Now, if you cancel stuff before you clean it up, before you start distributing and stuff, you will get it wrong every time. Let me get rid of that again. I want to get all that stuff out of the way. If you cancel before you combine, you get it wrong every time. Because guess what? This answer turns out to be, in the top, I got x squared plus 2x minus 1. In the bottom, I got 5x plus 13. That's what I got. I combined everything. I did all the totaling up and smushing together that I could. If you don't combine first and you just start knocking stuff out, you're making up your own rules, and those rules are going to lead you to the wrong answer. So, that's the final answer for this problem right there. That's it. Let's take a look at another type 2, please. Because type 2s are sneaky. See this one? This time I could put a 1 under here, so I got 1, 2, 3, 4, 5, 6 fraction bars. That is definitely more than 3. I am also going to take the entire top and the entire bottom, and I am going to multiply it by the LCM, which happens to be x squared in this case. So let's see, in the top one, x squared times 1, I get x squared. X squared times 9 over x, I get minus 9x. X squared times 14 over x squared, I get 14. There's nothing there to combine, but let's see what happens in the bottom. If I multiply x squared times 1 over x, one of these cancels one of those. I get x. And then I'll get a minus x squared times 7 over x squared. Oh, they're totally gone. I get a 7. But when you check the answer for this particular problem, you get x minus 2 for an answer. Why do they have such a tiny answer? Okay, here's the thing that we haven't run into a lot, but the top part does factor this time. X and x, that'll give me x squared. Last sign's positive 14, so I need a minus 2 and a minus 7 to make that work, because this guy is a minus 9. And then what can I do? I could take this one and that one, I could knock them out. Let's make that look a little cleaner. If I had factored this, it would have looked like that. On the bottom, I could have put that one in parentheses, and then I could have knocked them out, and there would have been my answer for this question. Now, I have told you guys, you don't have to worry so much about reducing in some of these problems. The last step right here, this part here is when we're simplifying. When we're going to simplify, that's when you try to factor and cancel. So once again, when it comes to these double fraction things, you only try to factor and cancel at the end. And you never try to cancel before you combine stuff. So you try to make stuff as small and compact before you start messing with it. So let's see. See this guy right here? What do you think this is? Type 1 or type 2? It's type 2. What do you think the LCM is? Coolest looking guy here for A's is right there. Coolest looking guy for B's is right there. So I'm going to take the whole top and the whole bottom, and I am going to get rid of these little circles here, and I am going to say I'm going to multiply the entire top part by a squared b squared and the entire bottom part by a squared b squared. Now, when it comes to single letters, people start getting goofy and they make mistakes because they want to multiply the top by ab and they want to multiply the bottom by a squared b squared. You do not get to multiply the top and bottom by different things. If you do, you will lose. You made up your own rule, and it's a bad rule. So let's see what lives through this. Be careful. You got to be a good bookkeeper. This first one, when I multiply it here, I will get one of these b's to cancel one of those b's, which will give me a cubed b minus one of these a's is going to only knock out one of those. So ab squared times b, I'm going to get a b cubed. That's the top. Look at how GCF-alicious that looks. It looks super GCF-alicious. Let's look at the bottom now. When I do the bottom, when this guy gets multiplied, the b squareds go away. I still have an a squared. Minus. Here, the a squareds go away. I still have a b squared. You do not get to just go, oh, I'm going to do this. I'll just do one of these for one. No. Those are not monomials. What's the top part? The top part is a binomial. The bottom part is a binomial. Do they match exactly? No. But like I said, look for GCFs. They're really hidden gems for you sometimes. I could take an A out, and I could take a B out. Let's do that right here. If I took an A and a B out of the top, what would have to be back here? What would I get? A squared, I think, minus, think about it, what would I need to get this part back? Do you see it? And then I go, wait a minute, let's get a black pen because I'm about to knock you out. Mama said knock you out. What's left? Bam! Now you might have to watch this video more than once. There's a lot of fresh moves in this. They are fresh and def in a dope fly way. So you got to be careful. So let me ask you, is this guy type 1 or type 2? Because the last thing I have to mention here is if you try to do a type 1 like a type 2 or vice versa, you will be the saddest kid in this class. So, let counting be your guide. How many fraction bars do you see? And if you see 3 just like I do, then you know that this guy could be written as x plus 3 over x squared minus 3x minus 4 divided by 2x plus 6 over x squared plus 3x plus 2. And then you might say to yourself, hey, these complex rations with double fractions that are called double fractions are not so tough if I handle them the correct way. So this particular problem, you know what? I could have written it like a multiply question right off the bat. I can't factor that in the bottom here. Hey, this guy is x minus 4, x plus 1. I could factor it times. Let's flip this in our minds. I would take a 2 out of that, G, C, F. It's in the game. And then up this guy right here, if it goes to the top, Bamarooney, Posituni, check that out. And then I could say, those guys are done, those guys are done. What's left in the top? X plus 2. What's left in the bottom? There's a 2, don't forget the small stuff. And there's one of these. Shazam, there's my answer. Okay, so guys, double fractions. There's 2 types, type 1 and type 2. Know the difference. If you don't know the difference, when you're counting fraction bars, you could count 3 or less. What do you mean less? You never said that. Well, what if I had something like 4 over x over 3? I could then make it look like that, and then I'd go, oh, I could make it. So I did say something about that. Then you go 1, 2, 3 fraction bars. That's the type 1. Anything with more than 3 fraction bars, that is a type 2. So we'll say 3 or less, and over here we're going to say 4 or more. And that's how you know the difference between which thing you're looking at. Over here, this is rewrite like division. Over here, you use the LCM to help you knock it out. Like Mama said. Mama said knock you out. And if you listen carefully to the song, Mama Said Knock You Out by LL Cool J, listen to the words carefully. It's about complex rational expressions. It is. It is. Okay, so guys, here's your stuff. Once again, there's 1, 2, 3, 4 questions. Why do you think I grouped those 4 together? Why do you think I grouped these 4 together? Okay, so give it a shot, give it a try, see if you can get these 8 total questions done. And those are your 8 answers when you finish. Okay, good luck, guys. And if you need extra help, remember, jump back in the room and ask me for help. Bye-bye.